Hello everyone, my name is Shaun Levick and this is a tutorial in the Environmental Monitoring and Modeling class of 2017 at Charles Darwin University. I'm picking up where we left off yesterday. This is our Earth Engine, this is the Earth Engine platform, and we've been working through Lab 2, found under the Teaching tab of my group website, geospatialecology.com. And just to quickly go over what we went through yesterday, we'd gotten to the stage where we were able to search for a Landsat 8 image collection, filter it by date, and plot NDVI over time. We handled cloud cover in this case by making use of the median reducer. And for today's lab, I want to show you another more advanced way of doing this. So let's go over now to lab number 3, which is continuing with time series analysis in Google Earth Engine. Prerequisites are the completion of labs 1 and 2. So far we've learned how to search for a single image and display it in the map environment. But from an environmental monitoring perspective, we will often be interested in how and where landscapes and different components of those landscapes change over time. In this instance, the time series of imagery is extremely valuable as it allows us to trace patterns of change over time and gain better understanding of ecosystem dynamics. So first up, let's clear our script from yesterday. That's gone. Which area should we work in today? Let's pick somewhere we haven't been yet. Maybe, how about up in Cape York? Let's just zoom in to an area up there. That looks interesting. Northernmost point of Australia. We're going to be using the Landsat 8 collection again. Let's see which one we'll be using. Before I get started, I'd like to just acknowledge the Google Earth Engine team for developing this processing environment, as well as the Geospatial Analysis Lab at the University of San Francisco. We're going to be using a very nice script today, and this was developed by Nicholas Clinton and David Saar. Dave is an old friend and colleague of mine, and this is a really nice script to look at Landsat NDVI time series. So we're going to make use of Landsat imagery today again, and although the spatial and temporal resolution of Landsat is slightly lower than Sentinel-2, it's an incredibly important program for Earth science as it provides valuable records, the whole program dating back to the 1970s using Landsat 5 and 7. The current Landsat instrument in orbit is Landsat 8. Just a note on how time series data are handled in Earth Engine, because it's a little different to other remote sensing and GIS platforms. Time series in Earth Engine are represented as image collections. This can make time series analysis complicated because there is a different time series in each pixel. The size or the length of the time series can vary across pixels. The thing to remember is that missing data can occur in any pixel at any time due to clouds. So if we think of an image, and ideally we build up a stack over time, and for each pixel we can drill down through time and look at how the reflectance values or the NDVI values change through time. But if there's clouds in a certain image, there's going to be gaps in those time series, and that's why it can vary across an image. So thus far we've used the filtering technique to filter by cloud cover, but what that is doing is it's removing an entire scene from our collection. So if there's been more than 20% cloud in an image, we've been discarding it. Now, if we look at an area like this, up over the ocean, it's often going to be quite likely that we have quite a high proportion of clouds, particularly in summer, over the ocean. And our filtering to date would be discarding these scenes, although there may be useful pixels over some parts of the land. So this script that we're going to look at helps us preserve the best data available by only masking out the clouds and not discarding an entire scene containing clouds. So the first step in the analysis is to import data of interest and plot it out at an interesting location. We're going to use Landsat 8, top of atmosphere reflectance again. So in our search bar, we type Landsat 8, TOA pops up, we click that and import it. What are we going to name our collection? L8 TOA. So we just type over here, L8 TOA. And then we'll make a single point geometry with the geometry drawing tools, position it at our location of interest, and name it ROI. So let's come over here, use the teardrop icon, drop it where we want it, and call it ROI. Hit enter. Now we are ready to go. Let's have a look at the code. Now this is a much longer piece of code than we've used so far. Let's just copy in the whole block, just the first block, paste it into our scripting environment, and let's have a look at what we're doing here. This field contains the Unix time in milliseconds, so we are defining a variable called time field using a system time start. This is the part we haven't used so far. So as I said previously, we've been using the metadata attributes to filter by total cloud cover in a scene. What we're going to do here is call on the band QA. This is the quality assessment band. If we come back to this import of Landsat 8 and we look down, we have these 11 bands with reflectance data, but the last band, BQA, is a quality assessment band. And this contains information about potential cloud cover. So, and these different types of clouds, different types of errors have different coded values, which you see written here. And if you want more information about this, if you go back to here, we can click on the Landsat 8 handbook. And this brings up a very detailed document from NASA with specific details about this quality assessment. For the purposes of our course, I'm very happy for you to just use the script as it is here. Basically what this is it's identifying 3 types of cloud variables which relate to specific codes in the NASA handbook. And we're creating a mask where we're saying if there's clouds of type 1 or 2 or 3, we don't want them in our image, not. So we return an image with an updated mask. We will then use this mask and map it over our image to create to flag these points throughout our time series. We're going to add bands. This is similar to what we did yesterday, mapping the function across the image collection. We're going to add bands of normalized difference using bands 5 and 4, and we're going to rename that band NDVI. We're going to add a time band as well. We're going to add a band with the image years, and we're going to then remove clouds, add variables, and filter to the area of interest by using the variable filtered Landsat equals L8 TOA. That's what we imported our collection as. We're going to filter the spatial extent, filter bounds to our ROI. That's the point we've made. We're going to map through the collection to mask the clouds and add the variables. Let's hit run and just check that we don't have any errors. No errors pop up in the console. We don't see any changes to our map because we haven't asked Earth Engine to print us any information or plot us a map. So that's our next point. So we're going to plot a time series of NDVI at a single location. Let's copy this script, paste it in here. Now, to plot a time series, we're going to create the variable Landsat 8 chart, calling on these charting functions within Earth Engine. If I go over to Docs and go down to Charts, we'll see a couple of different options for producing charts. We're going to be using, what we want to plot is data coming from filtered Landsat, which highlight that properly. You'll see it marked over here. We're going to select the NDVI band, and we're interested in the point. That's our region of interest. We're going to plot a scatter plot. We're going to call it Landsat 8 NDVI time series at ROI. We'll add a trend line with a specific color and a specific width and point size. These are all things that we can adjust as we like. Now let's hit run and see what happens. Looks good in that we see the generating chart icon in the gears. And if we wait a little bit, very soon, and this time series pops up. And this is really fantastic to look at, because think about how quickly we've queried an entire archive of Landsat 8 imagery. We've removed the clouds, and we've calculated NDVI across that series. So if you do a quick calculation, we'll probably get about 12 to 10 scenes per year, and this is just a great, sometimes 2 scenes per month actually. So it's a large number of images that we've been able to query and plot this trend over time. Now, this is very useful for a number of different applications. You'll see our time series only goes back to 2013. That's because Landsat 8 has only been available since the 11th of April 2013. If we wanted to go back further in time, we'd need to make use of Landsat 7, January 1st, 1999 through to April this year. There are some issues in the later data sets. Landsat 5, we'd be able to go all the way back to 1984. Now, although this is quite a long and complex code, once you have it all set up, we can just save the script and always come back to it. And the really great thing and the power of this type of processing environment is that once we have the script set up, we can use it and apply it anywhere. So say we were no longer interested in what's happening up in Cape York, we can just click on our ROI to activate it. It's in editing mode. And we can drag this anyway. Let's drag it over to Kakadu National Park. Say exit. Let's just run our code again. And now we're just querying that archive at a different point, and we bring up a new Landsat 8 time series. There's really huge potential in this for environmental and ecological studies, bringing the power of these large archives and distributed cloud processing to ecology. So thanks very much for watching, and good luck with the rest of the course. Before signing off though, I must add that for the students taking part in my class, there is an assessment task which will be graded. Landsat 8 provides important continuity of the Landsat program, which has been providing us with ecologically relevant imagery since 1974. MODIS has been providing imagery since 2000 at a coarser spatial resolution, but at a much higher temporal resolution. The practical lab assignment 2 is laid out here, and I'll just quickly go through that. I want you to locate Mount Burgess in Western Australia, define a region of interest with the geometry tool, load up the Landsat 8 and MODIS image collections into Earth Engine, search for cloud-free MODIS and Landsat 8 imagery that intersect your ROI, develop a time series of NDVI for both image collections. Inspect how NDVI varies temporally within your defined area of interest. Write up a lab report with answers to the following questions. What drives the temporal trends in NDVI across your area of interest? How do trends in NDVI derived from MODIS and Landsat compare? What are the implications of between sensor differences for long-term monitoring of vegetation condition? And are temporal trends in NDVI correlated with rainfall? Please include graphs showing the temporal trends in your report. Include a zoomed-in map of the 500-meter scale bar of NDVI, draped over a terrain hillshade model for your region of interest, and append your final JavaScript code to the end of your report. Final lab reports are to be submitted as a single PDF document in LearnLine. And for some extra guidance on plotting time series from Modis, have a look at this link provided here. So, thanks very much everyone, and good luck.